and welcome back. In today's video, we're going to be exploring Class 7 Science Chapter 13, Motion and Time. Now there are three types of motion that we're going to be covering in this chapter. The first type is straight or linear motion. Straight or linear motion just tells us that the motion type is going to be straight. So the object is going to be traveling in a straight line. Okay, now in a circular motion, it means that the object is traveling in a circle. That can be when Earth is revolving around the sun in this, or there are when a clock is moving, then the minute needle is moving in a circle. So that's circular. Periodic motion is when repeats after a definite time, which is a pendulum. Now what happens in a pendulum? This is a pendulum and it's moving from there and then it's coming back and then going in that side and then it's coming back and then going on that side. So what is it? Periodic. Now slow or fast motion. Now slow or fast motion basically means if an object is traveling slower or faster, but no. In motion we are talking about when the same distance is covered in different times. Now, if someone is walking really slow and they went from point A to B in 5 minutes, they are walking slow, okay? But when you look at someone running from A to B really fast, but in a weird way, not in the straight path, but in a weird way. So they took 10 minutes. Now, which is faster? The slow walking person. Why? Because the slow walking person still covered the same distance, meaning from point A to B, but in less time. But this one took a lots of time, right? So that's the difference between fast or slow motion. Now speed. The distance covered by an object in unit time. Now unit time is kilometer per hour and distance covered by an object in unit time. So it is 50 kilometer per hour, meaning they have covered 50 kilometers in an hour. Types of speed. Uniform speed, which is constant speed. When an object is covering the same distance in the same time. Doesn't matter where they are, wherever they are, they have a constant speed, meaning that speed does not change. So sometimes it can be 2 kilometers per hour, 3 kilometers per hour. No. Uniform speed means that it's always one speed, meaning 1 kilometer per hour, 2 kilometer per hour, but it stays 2 kilometer per hour. Okay? Non-uniform speed is the opposite of uniform speed. Speed meaning different distance, different timelines, meaning their speed can differ wherever they are. So if they're taking 5 minutes to cover 50 kilometers, then they might take in UK they might take 10 minutes to cover that much distance, right? So that's non-uniform speed, meaning the speed is changing throughout their journey. Average speed. Average speed is basically when you have two journeys, which can be the speed of one can be 5 kilometer per 5. 5 kilometers per 5 minutes, and the other can be 6 kilometer per 6 minutes. Now, how do we get the average? Average is 5 plus 6 is equal to 11. And then you add the 5 plus 6 on the bottom, which is also equal to 11. Then you divide it how you would normally, 11 by 11, which is equal to 1 kilometer per minute or 60 kilometer per hour. Now how did that 60 come in? Because in 60 minutes is equal to 1 hour. And in 60 minutes, they're gonna cover 60 kilometers. So that's how we got it. Different instruments to measure time. Sundial. Sundial uses the position of sun to tell the time using a shadow. So if they have a clock like this, 1, 2, 3, 4, and so on, they're going to use the sun's position. Now, if they have a needle like that, the sun is going to project a shadow and maybe it goes till 7. meaning the time is 7. So that's how you use a sundial clock. Now moving on, water clock. Water clock is like an hourglass. So if you have a pot like this, you fill up with water, and there's a hole here, and then how much time does that water time to take? It will be like 1 hour. So meaning that 1 hour is fast. So it's like hourglass. How sand flows, waterproof. Pendulum clock. Now pendulum clock is a little bit of a thing that we're gonna go in detail. It uses pendulum to measure time. Now this is a pendulum. The circular ball is called the bob. Now the pendulum uses oscillatory motion. This motion is which pendulum uses. One oscillation is when the bob goes from the center, not from the other side, from the center to the extreme end. One oscillation takes about 1 minute in a pendulum clock. So the pendulum clock moves a second ahead, right? So the needle keeps moving. But if you apply more force to a pendulum, and it will move faster than 1 second. Now time. Time is equal to distance by speed. Time is equal to distance by speed. Speed is equal to d by t, and distance is equal to s times t. Now, how does that? Let's zoom in to see what I've done here. Now, we have wrote the same formula right here. So, just a second. Right here, we have used the same thing, but we have got a triangle here. Now, it has dst. Now, if you're measuring the s, you cover up the s, and what are you left with? D by t. Now, to do that, I've got numbers as well so that we can prove our formula. Now, 2 is equal to 8 by 4, which is also 2. So that's one formula. Now, if you're measuring time, then you cover up the t. Now, you have d by s, which is the formula. Now, 4, meaning this is the t, right? 4 is equal to 8 by 2. Now 8 by 2 is 4, so meaning that formula is correct. Now we've got another one. If you cover up d over here, then it's equal to s times t. So you have 8, which is our d, times 4, which is our t, and then times 2, which is our t. Sorry, no, our s, our speed. Hope you got that. Let's move on. Odometer tells how much the vehicle has traveled. So if you look in your car, if you go on Trade Me, they will tell that my vehicle has traveled this much. If you want to buy this vehicle, then you can. If you don't, then you don't. Okay? Speedometer tells the speeder in kilometer per hour. Easy. Now we're going to be going into a little bit of a deeper topic, which is the distance time graph. Now it shows the distance and the time in a graph. So let's take the y-axis as distance, and let's take the x-axis as t. Now, 1, 1, 2, 3, 4, 5, and 1, 2, 2, 3, 4, 4, 5. Now, if my vehicle has traveled 1 kilometer, so the distance is in kilometer, in 1 minute, then we're gonna put the dot there. Then in 2 kilometers in 2 minutes, then we're gonna put it there. Then 3 and 3, 4 and 4, 5 and 5. So what is that? A line. That's our graph. Okay? Now we have got a straight line. So what does a straight line mean? It means that we've got constant speed. Meaning in 1 minute we've got 1 hour. So let's make a little time. So in 1 kilometer we covered in 1 minute we covered 1 kilometer. In 2 we covered 2. In 3 we covered 3. So when the kilometer is increasing, the minute is increasing. So that's called constant speed. Now if we have the line parallel to the axis, what does that mean? If you have a graph like this and you have a line like that, what does that mean? The vehicle is not moving, because the distance covered, the d, is staying the same while the time is increasing and increasing, right? So that's a stationary vehicle. A better way to draw this graph would be to draw it like that. So first a man went to the office, stayed there for 8 hours and came back. So you will still say that from here to there the vehicle was stationary. Okay? Now a curve shape. Meaning if you have a graph like this and you have a curve like that, or if you have a curve like that. What does that mean? If you have a curve like this, it means that in this much time, it covered this much distance. In this much time, this much more, it only covered this much more distance. So meaning the object is getting slower. Now over here, we have got in this much, we covered this much distance. Now in this much, we covered even more distance. In that much, we covered this time and this much distance, meaning the object is getting faster. Now we're going to be calculating the speed. Now, if you have an object like how we drew our first one, which was like 1, 2, 3 and 1, 2, 3 on the top, then we've got a graph like that. So what do? We calculate speed. What is the formula of the speed? D by T. So distance upon time. So let's take D by T. How does that work? Now, if you have 1 and 1, right? You have 1 and 1. Then you've got 3 and 3. So you're gonna take, how much distance did we cover? We covered 3 kilometers. So we're gonna say 3. How did we figure that out? Because our ending distance was 3 and our starting was 0. So we do 3 minus 0. So where we are minus where we started from. So that's 3 kilometers. By the time is, when we ended up, we were at 3 minutes. So 3 minutes. Meaning the speed of the vehicle is 1 kilometer per 1 minute. With that, we'll finish this chapter. Hope you enjoyed, hope you learned something new, and I'll see you in the next video. Till then, take care and bye-bye.